Yes, hi again. This is George Lerakis from Montreal Math and Physics Tutoring YouTube channel. And today I would like to talk about how to find the equivalent resistance of two or more resistors. I know that a lot of the students, they find this topic challenging. Specifically if you have a difficult combination of resistors, students have problem mainly because they don't know from where to start, and also they don't know which resistors are in parallel and which are in series. How you can solve these kind of problems is that really doesn't matter where you start in the circuit, and to decide which resistors are connected in series or in parallel, you should know that resistors that are connected in parallel, they end up on the same nodes. So, let's try to do an example, and actually this example will be a difficult example because I would like to show you that with the method that I'm using, any problem can be very easy. The difficulty of this problem, 9 out of 10, that's the difficulty of the problem that I will be doing. But as always, let's write the brief theory. When you have resistors R1 and R2 connected in series, you have that the R equivalent is equal with R1 plus R2. And whenever you have resistors that are connected in parallel, the equivalent resistance is 1 over R equivalent is equal with 1 over R1 plus 1 over R2. Okay, so that's all the theory you need. And now let's do the problem. As I said, the problem that we'll be doing, it's a challenging one. So we have the point A here, and then you have a resistor here, then you continue, you have another resistor here, then you continue, you have another resistor here, then you have another resistor here, and then you have another one between here and here, then you have another one between here and here, and another one here, another one here, another one here. Finally, we have the last one here. Yep, that's it. Okay. Again, this is a difficult problem, but my point here is to show you that when you use what I will show you just in a minute, any problem, it's easy. So let's put here the values for the resistor. So this is 6, this is 4, this is 10, this is 2, this is 8, this is 6, this is 6, this is 4, this is 8, and this is 8. So, and of course we have to find the equivalent resistance between points A and B. So, number one step is you put the letters on the nodes. So notice any point that they're connected 3 or more lines. So one will be this point here. So let's say A, this is B. So let's say this is C. Another one is this here. So this is D. Another one is here. E, F, G. And of course, the resistors are always in ohm. Okay, so now what do? I mean, we try to break this circuit here. We try to break it down into an easier circuit. So, I mean, we start, as I said earlier, you can start from anywhere you want. So usually we start at the end of the circuit, so we can start from A. Okay, so now let's draw this here, the first resistor, which is the 6. So now we have this point here, C. From C, we then continue to D. So let's write also the D. So this will go to D. This of course 4. Okay, so now what do we see? We see that, as I said, resistors that they end up on the same nodes, which means they are between the same letters, they are in parallel. And that can be resistors or resistor with combination of other resistors. So that means that D and E, we have these two nodes. So this combination of resistors 10 and 2, and this here, the 6, they are in parallel because they start and end in the same point. So that means that we can do it like this. So this is 10, this is 2, and of course this point here, it's E. So here is E. So, and you know, since we said that this combination with this they are in parallel, so we can add also this resistor here. Okay, so now what else we have? We have now that after E we go to F. So when we have that between E and F, we have the 8. The 8 ohm resistor. And now, what do we have? We have that if you check these two nodes, D and F, you see that like this point here, which will be F, this point here is our F. So you see that all this circuit with this 6 ohm resistor, since they end up on the same, they're between the the same nodes D and F, that means that all these actually with the 6, they are in parallel. So that means that we have to add here another 6, which is this here. And now what do we see? We see that, of course, after F you have G, so in between F and G you have 4, so this will be our G here. So we said that between F and G you have the 4 ohm resistor, and now you see that D and G, these two nodes, they have which resistor or combination of resistor they share these 2 points. It's all this here, all this including the 4 and the 8. So that means that between D, which is this point here, and D and G, sorry, between D and G, you have these are in parallel with the 8, so this here is 8, and now C and G, they include the same, they include all this combination here, which is in parallel with the 8, with the other 8, which is this here. And you come to G, which is this point here. And of course, between G and B there is nothing. So that's how we break down this into this. So now let's recap. So what we have, we start from A, you go to C. Now you have that these two with this, they are in parallel. So then all these with this, they are in series, and then this with the 6, they are in parallel. Then you include all these now with the 4, they are in series. Then all these with the 8, they are in parallel. And finally, this with this here, which is again 8, which is this here, they are in parallel, and that's how you calculate it. So let's now calculate the arithmetic value of this resistance here. So here I would like to start from the other way around, like going from the inside of the circuit towards the outside. So as we see here, these two resistors, the 10 and 2, they are connected in series. So that means that all this is 12, and the 12 is connected in parallel with this here, which is 6. So that means that 1 over R, let's call this DE, like the equivalent resistance between D and E, it's equal with, we said this is 12, so it's 1 over 12 plus 1 over 6. So if you put here everything under the same denominator, you should multiply this by 2, so that will become 2 over 12, so it should be 3 over 12. So that means that the RDE, which is the inverse of this, will be 12 over 3, which is 4. Now, the 4 now is connected with in series, with the 8. So that means that from D to this point here, F, the resistance is 4. The equivalent resistance is 4 plus 8, so that's 12. So that means that RDF is equal with, we said 4 plus 8, so that's 12. So now all this combination here of resistors, which we find that is 12 ohm, it's connected in parallel with this here, which is 6 ohm. So that means that let's say this is, let's say, part of the let's say prime. So this is part of the whole resistance from D to F. So that means that since all this is in parallel with this, so that means that 1 over RDF, just to make clear that this is different than this, has to be equal with 1 over 12 plus 1 over 6. So that's equal with, again here we multiply this by 2, so that should be 1 plus 2, 3 12s. So that means that the RDF should be 12 over 3, which is 4 again. And now we are here. And now all this that we calculated, the RDF, is in series with this here. So that means that the R from D to G, so let's say R from D to G has to be 4 plus 4, so that's 8 ohm. And now all this now from D to F, it's also in parallel with this here, which is 8. And again, let's say that this is the prime, and the final one between D and G, it should be 1 over R D G. It should be all this, so it's because again all these with 8 are in parallel, so that should be 1 over 8, which is, all this plus 1 over 8, which is this here, so that's 2 8s. So that means that the inverse, which will be the RDG, has to be equal with 8 over 2, which is 4. And now you see that all this, which is the 4, is connected in series with this here. So that means that the R from C to G is 4 plus 4, so that's 8. And now we are from here to here, and now all of this from here, from C to G, which we said is 8, is also connected in parallel with the last one in parallel, which is this here, the 8. So that means that, let's put here the prime again to distinguish from the RCG, which we want to find. So the 1 over RCG, it's 1 over 8, which is all this here, which is all this, plus 1 over 8, which is this here. So that's again 2 8s. So it means that the RCG is 8 over 2, so it's 4. And finally, now all of this, which is the R from C to G, it's 4. It's connected in series with this here, the 6 ohm resistor. So, and because between G and B there is no any resistor, so that means that these 2 points are the same. So finally the R from A to B, which is what we're trying to find, has to be equal with 6 plus the 4, so that's 10 ohm. So that's the numerical value for the equivalent resistance of this circuit here, which again, it's a complicated case, but I did it in order to show you that if you use my method, which to recap is, doesn't matter from where you start, when you try to find the equivalent resistance, and also that resistors or combinations of resistors that are between the same letters, they are in parallel. The rest are in series. So in this way, you're not to get confused when you try to solve problems of this in this section here. So thank you for taking the time to view this video, and I hope you find it useful, and bye for now.